Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you, and this is the DADM, which is Data Analysis and Decision Making 1 course under NPTEL MOOC. And as you know, this is a 12-week course, total duration being 30 hours, 60 lectures, and each week we have 5 lectures, each being for half an hour. And we are in the 9th week, which that means if you see the slide, it is on the 43rd lecture. So, if you and my name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you consider the concept of utilities and the decisions, which I said would be a major chunk later part, obviously we will come to the other things for multiple linear regression, ANOVA, MANOVA accordingly. So, what we are trying to do is that we are trying to basically analyze that given for any decision or on any utilities, what is the net worth based on which you are trying to take the decision. So, for the football match, considering the teams had one sets of wins and one sets of draws, and yes, a question on the which would definitely be raised from your side would be, what if the number of wins and losses are also different in both tournament 1 and tournament 2, which is case 1 and case 2, which is absolutely plausible. There is no question about that. But what I am trying to basically give you is an analysis that given that the wins and losses in numbers are same, but if the points accrued for the wins and losses are different, that how do you analyze the situation. So, they would definitely be, as you can understand, they can be definitely two ways of looking at the problem, and one is in the case where the so called net worth accruing for each and every decision is different, which is the main focus of this part of the discussion, and another is basically the total number of outcomes accruing for each and every decision is different, which is the number of wins and losses which you have, which is also dependent on the so called accruing concept of the values which are going to come. But the concepts of numbers which will lead on to probability would not be discussed in this set of lectures. Obviously, we will give fleeting examples for that, we will give some concepts about that, but we would not be discussing in details using the so called concepts of probabilities and probability distribution and theory. So, continuing the discussion, for case 1, tournament 1, team A has 100 points. That means based on the fact that you multiplied by the points into the number of wins, then multiply the points with number of corresponding points with number of losses, multiply the corresponding point with number of draws, sum them up, the value comes out for A is 100. Similarly, the values which comes out for B is 95, which means that A would be ranked higher based on the point scale. So, A would basically the winner, considering that A and B were competing for the prize. Consider tournament 2. Consider for this case, if I multiply the corresponding points, which is for the wins, loss and draw are different from case 1, tournament 1. And obviously, we are keeping the number of losses, number of wins, number of draws for A and B as same, which I did mention very categorically before when I started this lecture. These being the same, then the number of points of A would be 220, number of points accrued to team B would be 230, which means that now the ranking system would be reversed, B would be ranked higher than A, hence A would be the winner. Now, the picture which is coming out is that if I change the overall accrued points for any decision, if that total points level is changing, obviously it would mean that the ranking system would change, and obviously it would also imply that intrinsically the corresponding so called numbers would also be dependent on the point systems or the scaling systems or the scoring system. Yes, it will be true. But as I mentioned just before, this discussion has just started. I will also mention it once again that we would not consider the so called numbers based on the outcomes as being dependent on the accrued points. And I am using the words accrued points a number of outcomes, all this thing interchangeably, but basically I will come to what is the actual term which is used in our analysis. Now, here it comes. On a general nomenclature, we would have that the expected value or the so called the multiplication what we do for the points into the numbers, sum them up. So, that is basically utility which is given, or the net worth. So, the expected value utility given would for any decision would basically be multiplication of two terms. One is the functional form the utility, which is UW. So, that is what the points were. That means, for a win you win 5, or for a loss you basically lose -1, whatever it is. Similarly, for the case when the concept of ranking was there between in the first example, you gave 15, 10, 15 and all these things. So, those were basically the expected value, the value based on which you want to find out. So, here UW would be those points of 15, 10, 15 and so on and so forth. And the second value or the term which we find here. So, this second term is basically the probability. The first value is basically the utility. So, if you remember, I mentioned that how many such wins, how many such draws would be there for x1, y. So, this is basically what I need to find out, that numbers of wins and number of draws, this technically should be in the terms of a probability. Hence, we would basically have a probability distribution and a cumulative distribution, which for the time being we will ignore. That it will be a priori given, it would not be dependent on the utility as such. So, this is the utility, whether marked by red. So, what I want to find out is basically multiply the utility with the corresponding utility with the probability of the utility and sum them up, and basically that is what is basically be given by the expected utility. Here UW is the utility function, which is a function of the wealth, total amount of money which is given. Now, in the example of, say for example, when you are taking a decision when the values are 15, 10, 15, for the first example, I am considering the wealth as W and the corresponding utility also coming out as W. That means, UW is equal to W, even though in the actual practical sense it may not be true. I will come to the examples later on. So, here UW is a utility function which is a function of the wealth, while NW, which is the numerator for the right hand side, is the number of outcomes which with respect to a certain level of the income, and if you divide by the summation of NW, that would basically give you the probability. So, you are multiplying a value with its corresponding probability and summing them up to get the expected utility. Remember, in general utility values cannot be negative, and that means UW cannot be negative, but they may be examples where they can get negative values. For our analysis, to make the problem simple, we may consider the value to be 0 even if the values are coming out to be negative. So, if it is -2, we will consider as 0, if it is -13, we will consider it as 0, even though for actual explicit problem formulation and solution, we will consider the negative value also. So, let us consider another example. So, consider an example where a single individual is facing the same set of outcomes at any instant of time, but we try to basically analyze his or her expected value of addition or of utility separately based on the fact that there are two different utility functions which is applicable for him or her. So, what are the utility functions? In the first case, let me change the color. For the first case, it is basically a linear utility function which I am marking by yellow. For the second case, it is a quadratic utility function which I am marking by light green. So, the person has two different utility functions for different situations, it can change, and based on that I am trying to find out that how would that same person with two different utility functions rank the decisions. So, let us consider the problem as such. The outcomes are given on the leftmost column. So, these outcomes are what I will explain them, they are in 15, 20, 25, 10, 5 and 25, and the second, third and fourth column which I will just mark with So, I will mark it second, the third and the fourth. They are all corresponding to the utility function. Oh, I should be using a different, my apologies, it would be better if I use the second, if you can see it, the third and the fourth. They are with corresponding to the first utility function, which is also marked in yellow and is linear. The last 3 columns, 5th, 6th, 7th, are corresponding to the utility function 2, which is also marked in green. So, the first column basically outcomes remain same, and I will come to that why they are same later on. Now, basically it means that if let us go column wise. So, let us first consider the second column. So, these are the values of the wealth I am taking arbitrarily. So, I am considering wealths of 1.5, 2, 2.5, 3, 5, then it should basically be I am considering values of 0.5 and 5. So, this value there is some mistake, I will come to that. So, technically this value would be 0.5, okay, it would be 0.5 depending on my apologies, it's right. So, how do I find out these values? These values are, so if we use the first utility function, this is W 1 plus 1. So, the wealth values are given. So, the wealth values are 1.5 plus 1. So, that comes to be 2.5, which is right. 2 plus 1 is 3, 2.5 plus 1 is 3.5, 3 plus 1 is equal to 4, 0.5 plus 1 is 1.5, 5 plus 1 is 0.6. Now, I need to find out the probabilities. So, the probabilities are based on the outcomes. So, if I basically consider the total outcome, which is the first column. So, the total value is 100, which technically means out of the 100 such sort of outcomes which I have, if I find out the corresponding probabilities for the base case where my wealth is 1.5, if we consider the first row, utility is 2.5, then the corresponding probability for that utility, which is 2.5, will come as 15 by 100, which is 0.15. Similarly, if I consider, say for example, the 25 outcome, which is the last row, in that case the wealth is 5, the utility is 6, and corresponding to utility of 6, the number of times it will basically be supported would definitely be 25 by 100, which will be 0.25. So, once I have all the values corresponding to utility and probabilities, I basically multiply 2.5 into 0.15 plus 3 into 0.2 plus 3.5 into 0.25 plus 4 into 0.1 plus 1.5 into 0.05 plus 6 into 0.25. I add them up. So, this is what I do. For the first, it is 2.5 into 0.15 plus 3.0 into 0.20 plus 3.5 into 0.25, and let me put a bracket, plus 1, 2, 3. So, 4.0 into 0.10 plus 1.5 into 0.05 plus 6.0 into 0.25. This is the utility for the first case, which basically comes out to be, I will highlight again, is 3.825. Similarly, let me go to the next set corresponding to the second utility. So, second utility sets are this. So, so this value comes out to be 3 this value which I am just highlighting or marking. So, this comes out to be 3.825. Now, I remove this.
So, this is basically the calculation based on first utility. Now, I go to second utility. So, they would be 3.75 into 0.15 plus 6 into 0.2. Okay, I did skip it, sorry for that. So, if I want to basically have a 3.75 utility, what I would do based on the quadratic utility function, which is the green one, it is 1.5 whole square plus W2, that means 1.5 whole square 2.25 plus 1.5 would basically come out to be 2.75. Similarly, when I go to the second one, it will be 2 square, which is 4, 4 plus 2 is 6. Then if I go to the value of 3, where I am basically pointing my this pointer, so it will be 3 square, which is 9, 9 plus 3 is 12. If I go to the last one, it basically be 5 square and plus 5, which is 30. So, if I do it, so I get the second last column, and now I basically am doing the calculation exactly as I did. 8.75 into 0.25. So, plus the next value would be 12 into 0.1 plus 0.75 into 0.05 plus 30 into 0.25. That value, if I find out, the actual value would come out as 12.69, which is I am highlighting. So, if I want to compare the same type of decisions outcomes for the same person, but two different utility functions, you can find out the utility function 2 would basically give him or her, that person, a higher set of points based on which the ranking may change. So, we can have a different decision depending on the form of utility functions we are using, and you can have values as shown. Let us consider an 11th example, different one. Now, we have two different utilities, use one at a time for two different sets of decisions. So, if you remember, I did mention that the utility values functions are changing, the values probabilities are changing. So, basically it is considering both of them together. So, again I will basically mark it colored. So, the green one is basically for the linear utility function, and the orange one is for the so called non-linear utility function. So, linear value is Wi minus 5 and the non-linear one is 2 into W2. So, W2 is W1 W2 are the wells which would basically be the same, but I am just using a nomenclature in order to make you understand or give us a better picture. So, W1 and W2 technically they are not different, they are the same variable. So, utility function 2 it would be 2 into W2 minus W2 into 1.25. Now, the outcomes are given like this, which is the first column. So, outcomes are given as 8, 3, 4, 6, 9, 5, and the wealth values, which is also I am considering arbitrarily, are given by 4, 5. So, I should not be highlighting it, sorry, are 4, 5, 6, 7, 8, 9. Now, I do need to do the calculation. So, I basically mark them as green and orange. So, I will do it accordingly. So, for the utility one, the first utility based on wealth is W. W would be W 4 minus 5, which is minus 1, but as per the convention we will take as negative being 0. So, these are basically the values which I have. For the second value it will be 5 minus 5, which is 0. Third one will be 6 minus 1, which is 6 minus 5 is 1 is given. 7 minus 5 is basically 2 is given. 8 minus 5 is 3 is given. If 9 minus 5 is 4 is given. Now, what I do is that I basically analyze for the decision making A, where the utility is the one which is green in color, which is linear. Now, the decision has for 8, I will mark it also. So, and I will basically combine them accordingly, so to have a comparison. Even though I am marking it as green, it would be utilized for the second utility function also, remember that. So, I will keep changing the colors. So, please note it as I do it, so that means the things become much clearer. So, for decision A, consider utility as 1, which is green one. It is yes, no, no, yes, yes, no, which means a sort of go, no go gate, where the decision is allowed and the decision is not allowed. So, similarly for decision B, which will and also can be used for both for the green and the orange one, which is utility 1 and utility 2, it will be utilized. So, let me basically highlight this, because it will be utilized. Now, I am based on the green one, I am going to do the decisions and I will mark it accordingly. So, let me go one by one. For decision A, utility A 1. So, it will be, if it is yes, so the total outcomes would be 8 would be supporting it, and total number of such supports would basically come from yes, yes, yes. So, the values would be 8 plus 6 plus 9 would go into the denominator as it is. So, the corresponding value of utility is 0 multiplied by 8 divided by 8 plus 6 plus 9 is the first term. Next term, where it is yes, it is utility is 2. So, it will be 2 into yes. So, it will be 6 in the numerator and in the numerator, and in the denominator all the yeses, which is 8 plus 6 plus 9. And lastly, for the last value to be yes, again for utility is 3 multiplied by 9 in the numerator, and then in the denominator it will basically be the ratio. To convert into a ratio, it will be 8 plus 6 plus 9 as it is given. So, hence the value comes out to be 1.69. Now, I will pause here. I will basically go to the utility function 2, because I want to basically compare this. These are rather than comparison of the utilities, are a comparison of the decisions. So, what I would do is that let this color which is there on B remain. I will remove this color, because now I will basically analyze it with the second utility. Now, the second utility color is basically orange. Okay, done. Now, consider the second utility. For the second utility is basically a function of 2 into w minus w to the power 1.25. So, the outcomes are given as already mentioned 8, 3, 4, 6, 9, 5. I use that in the formula and get the utility values corresponding to 8, 3, 4, 6, 9, 5 as. So, the corresponding decisions for A. Now, you will see yes, yes for corresponding to the values of wait. Okay. So, these are not corresponding to B, my. So, I basically so these values are no, yes, yes, no, no, yes. I want to find out the corresponding probabilities. It will basically be multiplied with the corresponding utility. For the utility values which I know, if let me take one value, is how did 2.34 come? It is basically 2 into W2 minus W2 to the power 1.25, put W2 as 4, the value comes out to be as 2.34. If I consider, say for example, wealth of 9, so the utility would be function would be 2 into 9 minus 9 to the power 1 2.25, but the value comes out to be 2.41. Now, when I basically take such values, utilities have to be multiplied by the probabilities. Now, these are corresponding to the decision B. So, the decision B has no, yes, yes, no, no, yes. So, hence the corresponding probabilities which will be coming out for the case would be for utility 1 and 2. I am basically first highlight the utility 2, because I am comparing 1 with A, 2 with B, and again combine them. So, the utilities would be for decision B. Oh, decision B should have been a different color. My mistake, because coloring scheme they are not fine. It is quite confusing. Now, I combine them. So, basically it will be 2 point for the value of decision B would be basically be 2.52, which is this, multiplied by yes becoming here, yes number of times is basically 3 divided by how many such yeses are there, is 3 plus 4 plus 5 as it is. It is 2.52 into 3 divided by 3 plus 4 plus 5. Then for the next one, where it is yes 2.6 multiplied by the number of outcomes which is favoring, which is 4 divided by 3 plus 4 plus 5. Similarly, for the last one, it is 2.41 multiplied by 5 divided by 3 plus 4 plus 5, and if you add up, the values come out to 2.50. Now, basically let us consider both the decisions A and B are there for utility 1 and 2. So, consider decision B for utility 1. So, let me again change the color. So, now for utility 2, which is B, for decision B, and then I am basically considering the utility as linear. So, the linear functions would be, it is 0 because for the first case it is for considering the utility as the second one, it will be 0 for the utility for the first one using the decisions B, it will be in the case, it will be 0 multiplied, because that is a yes, multiplied by the corresponding frequency would be 3 divided by how many such yeses are there, it will be 3, 4 and 5. So, it will be divided by 3 plus 4 plus 5. The next one would basically be a utility of 1 multiplied by the outcome, which is 4 divided by 3, 4, 5. Similarly, for the last one, it is basically 4 multiplied by 5 divided by 3 plus 4 plus 5. The actual value comes out to be as, say for example, 2. So, when I am comparing the utilities U A and U B, which is for decision A and decision B only considering the linear one, then in that case level or the points accrued to B would be higher, as it is 2 with respect to 1.69 for 1. Similarly, when I compare basically the corresponding utilities only based on the second quadratic utility function, combining both the decision A and decision B, the values comes out to be, say for example, mark it with the green. For utility 2 considering decision A, it comes out to 2.5. When I compare both decision A and decision B for utility 2, the value comes out to be 2.5 in both the cases. So, with this I will end this lecture and continue the discussions further on related to the utility, and the decision based on is how the accrued points would be given, and also the probabilities can be found out. Have a nice day and thank you very much.